Hello, good day everyone, and welcome to our discussion for today. But before we discuss the topic, let me give you some hint or clue regarding to our discussion for today's video. So, have you been in a situation where you are making generalized conclusion from specific scenario? Like getting the next number by following some patterns? Or determining when you will leave for school based on traffic patterns? Yes, so our topic for today is all about inductive reasoning. So what is inductive reasoning and what are the examples of this? We will talk about in this video.
This is the definition of inductive reasoning. Inductive reasoning is the procedure of accomplishing a general assumption by examining specific instances. When you examine a list of numbers and predict the next number in the list according to some pattern you have observed, you are using inductive reasoning. The assumption form using the inductive reasoning is called a conjecture, since it may or may not be correct. Inductive reasoning is not used just to predict the next number in a list. It is also used to make conclusions, conjectures about specific observed patterns. Inductive reasoning is a logical process in which multiple premises, all believed true or found true most of the time, are combined to obtain a specific conclusion. Inductive reasoning is often used in applications that involve prediction, forecasting, or behavior.
Now that we know what is inductive reasoning, here are some examples.
Example 1.
So we have here an example number 1. Use inductive reasoning to predict the most probable next number in its list. So we have here 5, 10, 15, 20, 25, 30, and we need to predict what is the next number. By using the inductive reasoning, we need to examine of each term. So by difference of each part. So the difference of this part is 5. So the next preceding difference is 5. 5, and 5. So if you look up here, the difference is 5. So there are the constant difference, which is 5. So therefore, we could just say, by using the inductive reasoning, so the next number would be 35. By adding 5 here, so 30 plus 5 is 35. So the next number would be 35.
Example 2.
Okay, example number 2. In this sample, we are going to predict the next number by using inductive reasoning. As we can see in this sequence, there are two patterns. First is the positive, negative, positive, negative, and obviously, as we can see, in the first pattern, the last number is negative, so the next is positive. So this is positive for the next number. And as for the second pattern, we could say that the number here is a product of a number being squared. Let's say we set aside the negative signs. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. And obviously, square root of 1 is 1. So, we could say that the next pattern is 5 because 1, 2, 3, 4, and 5. And 5 squared is 25. So, this is 25. So the next number that's missing here is 25. And it is positive because of the first pattern, that is positive, negative, and positive. So the next number that is missing here is 25. This is the answer.
Example 3.
Look at this series of 1, 4, 2, 8, 6, 24, 22, 88, and 3 unknown numbers. As you can see in the series, it is neither in ascending or descending order. This could be a pattern combination of two logics. The first step is to find their differences. Starting from the left side, the difference between 1 and 4 is 3. The difference between 4 and 2 is minus 2. The difference between 2 and 8 is 6. The difference between 8 and 6 is minus 2. The difference between 6 and 24 is 18. The difference between 24 and 22 is minus 2. And the difference between 22 and 88 is 66. As we find their differences, we observe one logic of the series, which is every alternate difference is minus 2. By finding their differences, we are not yet able to find the complete pattern of the series, so we will try to use another method. Then we erase these differences except the numbers minus 2. Once again, observe the pattern carefully with the newly given logic. Let's try to find the relation between 1 and 4. If we multiply 1 by 4, we get 4, and minus 2 equals 2. Again, let's find the relation between 2 and 8. Apparently, we could apply the same pattern used in numbers 1 and 4. So, 2 times 4 equals 8, minus 2 equals 6. For numbers 6 and 24, 6 times 4 is 24, minus 2 is 22. For numbers 22 and 88, 22 times 4 is 88, minus 2, 86. Then we get our first unknown number. For the last two unknown numbers, we multiply 86 by 4 equals 344, minus 2, 342. So the complete series is 1, 4, 2, 8, 6, 24, 22, 88, 86, 344, and 342.
Here are more examples.
Use inductive reasoning to make a conjecture. Consider the following procedure. Pick a number, multiply the number by 8, and add 6 to the product, divide the sum by 2, and subtract it by 3. Use inductive reasoning to make a conjecture about the relationship between the size of the resulting number and the size of the original number. So, let's try an example. We say that let the original number number is 5. So 5 multiply the number by 8. So 5 times 8 is equals to 40. Add 6 to the product. So 40 plus 6 is equals to 46. Divide the sum by 2. So 46 divided by 2 is equals to 23. And subtract it by 3. So 23 minus 3 is equals to 20. From this example, we see that the original number is times 4 and it produces 20 from the result to the resulting number. Let's try another example. We say that let original number is 6. So multiply the number by 8. So 6 times 8 is equals to 48. Add 6 to the product. So 48 plus 6 is equals to 54. Divide the sum by 2. So 54 divided by 2 is equals to 27. And subtract it by 3. 27 minus 3 is equals to 24. We saw that from 5, the original number, it produces the final answer to 20. And from the original number 6, it produces the final answer to 24. We conjecture that the give procedures a number is 4 times the original number. So 5 times 4 equals to 20. 6 times 4 equals to 24. We conjecture that give procedures a number is 4 times the original number.
So hello everyone, this is the next example. An animal called kangaroos are considered the best jumping animals in the world. Due to their powerful hind legs, red kangaroos are the biggest and fastest kangaroos. Biologists from Australia observed some of them and they witnessed it can jump over 28 feet, 26 feet, 25 and 23 feet. Another biologist also observed the other kind of kangaroos, so-called narbarlek. These are the common ones. This kind of kangaroos can only reach up to 8 feet, 7 feet, 9 feet, and 6 feet. Make a conjecture based on the data. So we have our table here. Heights of kangaroos can reach. Red kangaroos, we have 28 feet, 26 feet, 25 feet, and 23 feet. So narbarlek kangaroos, we have 8, 7, 9, and 6 feet. So based on this table, we can say that the smallest height of a red kangaroo's jump, 23 feet, is almost 3 times higher than the greatest narbarlek kangaroo's jump of 9 feet. So we have our possible conjectures. Number 1, the height of a red kangaroo's jump is about 3 times greater than a narbarlek kangaroo's jump. And number 2, the height of a red kangaroo's jump is greater than a narbarlek kangaroo's jump. So that is all for this example. Thank you.
Use inductive reasoning to predict the next letter in the following list: J, F, M, A, M, J, J, A, and D. As you can see, there are 2 letters missing. If you observe the pattern, J stands for January, F for February, M for March, A for April, M for May, J for June, J for July, A for August, S for September, O for October, N for November. D for December. So the missing letter are S and O. That's all for the examples. But before ending this video, try this.
Let's try this in order to assess your learnings in these lessons. Directions. Find the missing number by using inductive reasoning.
That's all. Thank you for listening and watching.